Let's carry on with our drafted wheel 2 part. Let's add a little bit more cosmetic detail to it. So right now everything's been designed appropriately. We have draft on everything and theoretically it should work for pulling from a mold, but I just don't think it looks very good. So I want to add a little bit more detail to make it look better. So to do this, I'm going to add a few cutouts to make it look more like a spoked wheel. Now, I want to take the second to really talk about some of the flexibility inside SolidWorks. So I'm going to start by adding a sketch on the back face, the same place we added the sketch for our ribs, and create a sketch here. Now, the reason I'm doing it here is because it's easier to see the ribs in this view. Now, of course, I could view it from any angle I want to, but in this case, it just makes it quicker and easier. I'm going to start by using the center point circle tool from the origin, and I'm going to just manually start dragging it out, and I'm going to say 0.375. I'm going to draw another circle from the origin, and this one's going to be 0.75. Then I want to draw two lines, and the lines are going to go from the outer circle to the inner circle. Now, you can see by default, SolidWorks is drawing some dashed yellow lines. One of those lines is going directly through the origin. This is adding a coincident relationship between the line and the origin, basically telling you that if you extended it, it would intersect with the origin. I'm going to double left click, that ends that line, but still keeps the insert line tool active. And I'm going to add a very similar line from the bottom, going up to the right. And again, I want to go to that persistent constraint where it's adding that coincident with the origin. Now, if for some reason, when you're sketching, you don't have these persistent constraints that's adding a relation with the origin, that's not a problem. You can go ahead and select the line, control select the origin, and just make sure you use make coincident. That allows you to drag the line up and down, and it'll keep it coincident with the origin. The next thing we want to do is draw a line for construction from the origin out to the left. And then I'm going to use my trim entities, power trim option, and I'm just going to hold down the left mouse button and drag it through the outside areas that I don't need. So this has left us with this sort of wedge shape, and this is going to be our cutout. But you'll notice that we still don't have it fully defined. Everything is blue on the top edge and the bottom edge, but the outer arc and the inner arc are both black. So there's a couple ways that we can fully define this. The first of which is by selecting the arc, control selecting the endpoint for our line, and adding a midpoint relation. Now what this midpoint relation does is it makes sure that the upper and lower edges are equal. So that means we only have to add an angle dimension to one of them, and then we know that it's consistent. Next, I'm going to use my S key, go to my smart dimension, and dimension from this construction line to this upper edge, and add a dimension here for an angle. Now you'll notice by default, it's adding a vertical dimension because I already had this point selected. So you need to hit escape twice. It still keeps the dimension tool active, but it gets rid of both selections. Now we can go ahead and add a 20-degree dimension here. We can exit the sketch, and we can start to do an extrude cut from our features tab. Now, one thing I want to note is as we do an extrude cut, I want to select through all. This will make sure that the extrude cut goes all the way through my part. But remember, we do need draft here. If I select draft, it's going to automatically draft inward, or I can draft outward. Now, depending on where you place this sketch or where you want it, which direction you want to pull the hole from, you need to determine whether or not you want to draft outward or inward. Now, if we look at this from the front, if we draft outward, as we have it here, the hole is going to have to be pulled from the inside portion of the mold or the core. If we draft inward, then it's going to be pulled from the cavity. So this is very important that you understand the difference here and that we make sure that we also link it to our global variable. So currently it's set to be pulled from the cavity section of our mold. You can see that as we look at it from this view, we can see those faces. If we were to look at it from the back side, when we zoom in, we can't see any of the faces here. So this means that the mold that we're pulling from in this direction would not be able to see those faces or pull it from the mold. Let's go ahead and add a few fillets in the corners, and we'll make it a pretty small fillet. Let's say 0.05. We'll select one of the interior corners, and we're going to use the options to apply to all four interior edges. Now, if you want to make this even smaller, let's say 0.03, to make it squared off in the corners, that's still fine. This radius value won't affect anything else that we do. Now we can select Cut Extrude 2 and Fillet 3, and use our Linear Pattern dropdown, go to Circular Pattern, select the center of our hub for our revolve axis, use 360 degrees, 6 instances, and equal spacing, and say OK. So now this looks like a very different wheel. So as we look at it, we have pretty large cutouts, and if we look at the back, You can see the ribs that we already added are adding structure to the area where we don't need all that extra material here. So this makes a lighter part, it's more cosmetic. Overall, it's just going to look better on the part. So let's go ahead and save this, and we'll do a save as, and we'll simply add draft wheel 3. So now we have 3 different versions. The original base shape, the version that has the ribs on the back side, and then this third version where we have the cutouts.